Welcome to this workshop on the signal metadata format, Sigmf. This has been an effort that has been ongoing within the GNU Radio community and a lot of other interested parties for several years now. And excitingly, just on January 7th, it hit the 1.0 release. So there is now a published specification on how to construct, verify, store RF signal recordings, as well as quite a lot more with associated metadata. And so Ben Hilburn and Jacob Gilbert are going to be leading the workshop today. Kyle Loge is not in the list as far as I can tell, but has been a significant contributor to this effort. So thank you, Ben and Jacob, for leading this up, and we'll pass it off to you to continue on.
Okay, sounds great. Thanks, Derek. So I do recognize a fair number of names in the participant list. Some of them I haven't, I think, seen in several years. So hi to those of you for whom it's been a while. I think one of the things that Jacob and I would really like to use this time for is some interactive chat about, now that we have a stable 1.0 tag, where we intend to continue backwards compatible feature development and bug fixing and that sort of thing. Within that, where do we want to go, both in our development branches that remain backwards compatible, and also looking ahead, what are things that we want to do that might actually not be backwards compatible, and what are the use cases that we haven't thought of or we don't fit yet, and what do you need out of Sigmf for your systems? So I think we do want to spend a fair amount of time in that interactive portion. That said, here at the top, I think we'd like to take some time to kind of step through what is included in the 1.0 release, where are we at with some of the key new features that were added, including support for things like non-conforming data sets and collections, right? So, which is both how you organize different types of recordings that were all part of the same experiment, as well as things like recordings from multi-channel phased arrays. But before we get going, I'd love to get just kind of a feel for what kind of background we have here in the audience. I see people in the audience that I know are already very deeply using Sigmf within their own companies, and in some cases operational deployments and networks. I don't know for a lot of others though. If you don't mind, in the chat, if you have never used Sigmf before, or you're sort of coming in cold, so can you just wave your hand in the chat? All right. Oh, hey, Andrew. Andrew, how's it going? Oh, why, thank you. Derek, thank you for the poll. I assume that was Derek. Jacob, did you do that?
No, I did not. This
Okay.
is great, though.
Your helpful event moderator will attempt to augment this experience as much as possible.
Okay, so we've got 3 that have never heard of it, and then 15 that know a little bit about it. And then everyone else has touched it in some way. So let me start out then with, we'll do a quick crash course in what Sigmf is and the way that it was designed and sort of our design requirements going in for it. So first of all, Sigmf is a specification. Really, you could think of it as both a specification for a format as well as a schema for metadata. But fundamentally, it's a specification for storing digital recordings of sampled data, and metadata that describes it can be arbitrary metadata that describes it at rest. So it is not one of the most common questions we get is, how does this relate, for example, to Vita49? So Vita49 is a packet format, right? That describes what data looks like over the wire. Sigmf describes what data looks like at rest. And I think actually almost everybody I know that's using Sigmf in operational systems and sensor networks uses a combination of Vita49 and Sigmf. So Sigmf is fundamental. All the metadata is described in JSON, and the storage format for the data breaks it out separately from the metadata and is specifically designed to facilitate things like easy access, high rate recording and playback, and being able to basically skip through the data just to hit the pieces that you care about very quickly, using some very simple constructs. So there are, I'll just run through these very quickly. There are 10 high-level design requirements that we set out with Sigmf. So the first was maximizing the speed at which computer programs can read and write to recordings. So a recording is a fundamental unit of Sigmf. We can, and actually, Jacob, if you don't mind, can you, while I'm talking through these, can you throw up that ASCII diagram and the specification? And I'll talk to that in a second.
Sure.
The second one, and this came from the designer's experience using things like Vita 49, where, in fairness, Vita 49 is really more of a framework for defining schemas for packet formats more than it is a specific schema itself. But anybody who's worked with those sorts of systems has probably experienced the problem where, you know, two vendors say that they are both Vita 49 compliant, and in fact, they can't understand each other's data. And so one of the fundamental goals of Sigmf is to define what compliance means, the specification, in a way that if a recording is Sigmf compliant and you have a, for example, a reader application that is Sigmf compliant, you are guaranteed to be able to understand the fundamentals of that data. Second is minimizing the requirements to actually interact with recordings. So we mean that both in terms of the complexity of code logic, software dependencies, and even, for example, the capabilities of your hardware. Providing a way to link many time variant fields together. So this was another one that we weren't capable of this until version 1.0. We are now. So what this refers to specifically is the ability to understand how two recordings of, or two streams of data relate to each other in a synchronized way. So the example I gave before is if you have a receiver, for example, in a moving vehicle, and you are recording the sample data that you are receiving from the radio in that vehicle, you have probably at least two very important data streams that you care about. One is the radio data itself, and the second is where is the receiver, or what direction is my aperture pointing, right? And being able to organize that information in a common way and link them together is one of the fundamental goals. Being able to share recordings of data without sharing the entirety of the recording. So this came out of experience that we had both in the GNU Radio community and especially working between GNU Radio users and users of other, for example, popular open source software tools like in Spectrum, where interoperability of RF data recordings and the ability to move those around, both mechanically in terms of, like, I have RF recordings are very, very large, right? How do we reduce that? But also, how do we do it in a way such that there actually is interoperability between these tools? And if you're developing a new tool or you're integrating RF playback or RF, you need to be able to understand RF data in a new piece of software that you're writing. How do we make that as simple as possible? We wanted to allow for arbitrary metadata not defined by the specification, while also still guaranteeing maintaining that promise of compliance where anybody can understand it. Representing the metadata in a way that's easily parsable, searchable, and indexable. So this came out of really experience with systems like HDF5, where HDF5 kind of looks like a file system on its own. And it does what it sets out to do very well. But one of the things that we really wanted to be able to do was to define the metadata in a way that allowed the users to store it or parse it or load it into databases in any format that was best for them, while still maintaining the semantics of the metadata itself. We wanted to keep the standard as easy to read as possible. So if you haven't looked at the specification yet, or I'm sort of using the word specification and standard interchangeably here, which is not accurate. But if you haven't read the specification itself yet, we do use some common approaches that you'll see in things like IETF documents. We did try to make the standard as easy as possible, and including things like building some examples into the document. And then lastly, ensuring that this is governed and maintained by an open source development process that anybody can participate in. We don't require copyright assignment, and there is no barrier to anybody influencing the direction of this. So that was kind of a fire hose, I realized, but those were the original design requirements. And Sigmf is the result of several years of work starting in 2017, leading up to this. And it's had a lot of contributions from a lot of different areas across private industry, government, both within the US and outside of the US, universities, non-university affiliated research centers, FFRDCs, UARCs, hobbyists. We've gotten a lot of contributions from a lot of places. So that's been really exciting. So before I throw it over to Jacob, I think I'll finish my sort of high-level crash course in Sigmf here with the diagram that you currently see on the screen. Just blurred out for me for a second, and it's back. Awesome. So starting with this box, the Sigmf recording, that's really the fundamental unit of Sigmf. So a Sigmf recording includes within it a metadata file that is written in JSON and a dataset file. The dataset file contains the sampled data. And the dataset file is either what we would call the Sigmf dataset. So it looks how the Sigmf specification says a dataset should look, which is really just raw data, assuming that it's IQ data, raw IQ data interleaved in a straight stream with no headers or footers or things like that. And then in version 1.0, we added the ability for Sigmf metadata to describe non-conforming datasets. And probably the most important example of a non-conforming dataset is a raw dump of Vita49. So one of the huge advantages to using Sigmf is the way that it's designed allows you to directly memory map the data from your software and then address it and use it according to the metadata. This makes it really, really easy to work with large data sets in software systems. And we continually sort of hit the problem where users who had Vita49 in use somewhere within their network wanted the ability to do the same using the Sigmf metadata schema, but describing these raw dumps of Vita49 that technically did not comply with what we said a dataset should look like. And so as of version 1.0, we now described how to go about describing non-conforming datasets, such as Vita49 dumps, with Sigmf metadata in a way that allows you to maintain that sort of very fast nmap capability. And then coming back up to the top, a Cmf Archive is basically a way to compress recordings. And then finally, the collection, well, not necessarily compressed, share a recording in a single file that may be compressed. And then finally, the collection feature is one of the newest features. That's a new feature in version 1.0. And that particular Sigmf collection file is how you describe the relationship between different recordings. So for example, in the example I gave before, right, where you have a one stream that's a moving radio or a spinning aperture or something, and another stream that's radio data. The collection file is how you link those. Or if you have a multi-channel phased array, the collection file is how you say, each of these recordings is actually one channel from a single radio system. So I'll pause the crash course. That was kind of close to 20 minutes of fire hosing Sigmf design stuff into the audience. I'll pause there. Does anybody have questions about sort of the fundamental design of Sigmf or what it seeks to achieve or anything like that? Otherwise, I think we'll kind of pivot over to where we're at and talk about what we're doing moving ahead. And really, like, feel free to either put it in chat or come off of mute, ask a question. Happy to talk about any of it. And actually, just to give a minute for people to type questions if they want. One thing I'll call out about version 1.0 is we tagged version 0.0.1 several years ago. And to be totally honest, Sigmf kind of took off a lot faster than we anticipated it taking off in terms of adoption. And so we fully intended to follow sort of the semantic versioning principles, right? Where any version less than 1.0.0 is considered not stable, and that you should not rely on any aspect of it not changing. And we tried to communicate that in the document, but it ended up sort of taking off so quickly and in so many areas that there were large groups and organizations and government agencies and departments and private industry who were using and relying on the existing Sigmf design as described in 0.0.1. And so there were a lot of things that we had talked about over the last couple of years that would have broken backwards compatibility with that design. And so what we decided to do was, just based on the level of adoption that the existing standard had already seen, we decided to put all of that stuff on hold, pour all of our time into making the previous 0.0.1 tag, bring all the features to it that we could, clean it up, refine it, and make it the best release that we could, and really treat that as version 1.0. Because regardless of what the version number said, in reality, the community had been treating it as a stable release for several years. And so we will continue that with version 1.0, and version 2.0 is all of the discussions that we've had over the last couple of years about cool new features or neat things that we want to start innovating on, but that aren't necessarily compatible with the existing standard. That's going to be 2.0. We will not break backwards compatibility with 1.0. I haven't seen anybody ask a question in the chat. Nobody's unmuted. Unless somebody wants to pop in now, I'm going to throw it over to Jacob.
All right. Thanks, Ben. I'm going to jump back over to the agenda slide I have. It is also the only slide I have. There's a good question in chat right now regarding GNU Radio's use of Sigmf. I have a specific agenda item for that we'll talk through. I don't have a tremendous amount of information, but we do have some notional plans together for that. So Ben really spoke to the Sigmf 1.0 release. That's great. I just want to highlight that in addition to 1.0 of the Sigmf project, which contains the specification and a Python module, Sigmf, there is a C++ lightweight header-only library, libsigmf, that will also have a 1.0 release probably later today. Libsigmf is one way of handling Sigmf in general. It's built with the concept of defining schemas and extension as flat buffers, FBS files, flat buffer schema files, and it allows you to pretty easily build in additional extensions for whatever your needs may be. It's not the lightest weight library. It does depend on flat buffers. And so it's just one example of a fairly feature complete Sigmf implementation for C++. The gr-sigmf module, which will soon be upstreamed, will likely make use of libsigmf for that reason. So one of the things that we did when we held this workshop in person at GRCon is we had sort of a segment dedicated just to user survey. You know, what are the needs in this area? Who's using this? How are they using it? What types of data are people storing with Sigmf? Coming from GNU Radio, this is a lot of RF data is being stored this way, raw time domain data off of an antenna, but we occasionally hear of other data types being stored. And I'm also curious about tooling, if people are developing their own tooling in-house for government or industry reasons. There is some existing tooling that supports Sigmf today. A great example is in Spectrum, which can be built with Sigmf. Mike Walters, I think, is on right now. He maintains that. It's a great example of how to use one very powerful feature of Sigmf that's been around since the beginning, which is the concept of annotations, where you highlight a specific time and possibly frequency section of a data set, and enrich that data with metadata about that particular segment. You might use this to highlight bursts of energy in Spectrum, or you might use it to highlight sections of interference or sections of saturation in a data set. There are a lot of reasons to do that, and in Spectrum is a very nice way to start using Sigmf and be able to visualize the annotation data that you've included. So with that, I'd really like to see, if anyone would like to bring up any sort of user requirements, examples of what they're doing, different types of data they're storing with Sigmf, tooling, anything of that nature. I'm going to pause here for a minute or so and let anyone jump off mic or jump into chat.
Yeah, this is Andy Clegg. I'm not using Sigmf right now, but I sort of have a question in that this is my first exposure to it, and I'm trying to wrap my head around it. But can I envision, let's say if I'm making recordings in Sigmf and I'm doing it with GNU Radio or something, can I imagine that I will have a large, file structure on my Linux machine that will contain all of the data files and the metadata files and things like that, and all in Sigmf format? So I might have, some directory with tens of gigabytes of data and metadata in it, in that the Sigmf, and I missed this about the Python library, but will there be a Python module or something that will allow me to access those data in Python with all of the necessary metadata I need to make sense of a given data set and get directories of my data and things like that? Or am I thinking about it the wrong way?
That's definitely the right way to think about it. Within the Sigmf project that's hosted on GNU Radio's GitHub group, there is a Python module there that is intended to provide that type of access. A Sigmf recording is comprised of, at its most basic, two files. You have the metadata file and the actual data set. Sigmf was designed to enable people who store raw data to add that metadata file and immediately have a Sigmf compliant recording. So by adding those metadata files, accessing those metadata files, the library that Sigmf includes, the Python library, allows you to get access to segments of data based on that.
And I think the only aspect of what you said, Andy, that I would tweak slightly is that the way that the metadata and the binary data are stored on disk are not mixed. They're fundamentally separated, and they're stored in a way that even if we're not using a Python tool, for example, or libsigmf, for example, in C++, you can easily interact with those files with standard POSIX tools, or even Python's mmap function. You can basically use that as a built-in to map the entirety of the dataset file without traversing the metadata. So they are separable. It doesn't combine it all into a single blob that you then can only get out of some Sigmf specific API. They are stored in really very simple formats, honestly, that you can interact with native constructs in almost any language that you care about.
Got it.
But we also provide the Sigmf Python stuff as well as libsigmf to give you sort of a Sigmf's context-specific API.
And the idea in GNU Radio would be that it would automatically generate the metadata file based upon your setting of, center frequency and sample rate and all of this other kind of stuff. It would generate that metadata file automatically for you.
Yeah, nailed it. And so this is this goes, I think, directly to Jacob's number 4 here. So there is currently a GNU Radio out-of-tree module called gr-sigmf. And I think the heritage of this actually goes back to an ESA-funded program into LibreSpace, and which created the first gr-sigmf. And I don't know if SkySafe built on top of that or started afresh. But SkySafe has a GNU Radio out-of-tree module called gr-sigmf, where they've implemented effectively exactly what you said. You can think of it really as GNU Radio, source and sync blocks that understand Sigmf, as well as the built-in ability to deal with the Sigmf schema. Because one of the gaps right now between GNU Radio's design and the Sigmf schema design is like the default tags, the default stream tags that you would use in GNU Radio to describe those things are actually different than the same string that we would use for that piece of metadata in Sigmf. So for example, like the string that you would use for frequency is different between the two, and it has to be translated. So there's 2 major efforts to call out here. The first is a little bit, actually, I'm not sure which one's going to finish first. So the 2 major efforts to call out here is first, gr-sigmf, which is currently an out-of-tree module, is going to be upstreamed into GNU Radio, and will become part of the mainline distribution. And those Sigmf blocks will be included in GNU Radio at large. Part of that work, gr-sigmf was originally written using RapidJSON, and that is being replaced with libsigmf. And once that work is done, gr-sigmf gets upstreamed. This will all be built in GNU Radio and provided out of the box. The other piece of it is moving ahead. We are going to align GNU Radio's default tag strings to Sigmf such that no translation is necessary. And as Sigmf's, we have a concept of canonical extensions in Sigmf. So Sigmf is namespaced, and in its core namespace, it provides basically the fundamental fields that you need to understand data. Like, hey, what was the sample rate this was recorded at, for example, right? But it also describes a mechanism by which you can create extension namespaces. And so one of the very first examples of this was the NTIA created several extension namespaces for the sensor network that they were building out at the time, and it had some things that they cared about. And so we have actually upstreamed some of the NTIA's extensions into the mainline Sigmf and effectively made those namespaces canonical. So there is now a canonical namespace for antenna metadata. And so as that library of canonical extensions grows, right, there will probably be further integration and alignment there with GNU Radio's stream tag names. So a little bit of a long-winded answer, but I tried to cover both sides of your question.
Yeah, thanks, Ben.
Within the Sigmf specification on GitHub, there's a directory for those canonical extensions, and you can go take a look there and see what it takes to write an extension. Some of them are somewhat involved. Some of them are extremely simple and add 1 or 2 fields. Many people who I'm aware of using Sigmf will have their own extensions for internal use, and the idea here is that you can extend the specification by providing someone a data set that makes use of your extension as well as the extension file.
Yep. And so just to, I guess, for the new folks in the room, the way that mechanism works is if you have a Sigmf compliant data set, even if it relies on using metadata described in an extension, you're guaranteed that anyone who receives your data set will be able to understand the fundamentals of it. They will be able to parse it. They could play it back through something like InSpectrum or radio. The sample rate will be right. Sort of the fundamentals of that data will be right. But they might not understand, or they will not understand the new pieces of metadata that you described in your extension. And so in order to do that, you would just also give them your extension description.
I have a question from Kevin Munns in chat.
Yeah, data type mismatches are one of the primary things that we set out to fix with Sigmf. That is super, super common, especially when you're mix and matching. Conjugated that wrong. Mixing and matching different SDRs. And in some cases, even the same SDR, but with different configuration where you can flop ND in this, or you've got network network coding over one and not the other. All kinds of bizarre things happen. And over and over again, right, we would hear horror stories of some field collection. And 2 weeks later, everyone gets back to the lab. It's like, okay, now we have to reverse engineer what the data actually is. we're not sure what this byte means in this file versus the byte over here in this file, because it looks like it was recorded backwards or something. And so yes, Kevin, to your point, formalizing what that is very strictly is one of the things that Sigmf requires. And so in the specification, there are certain metadata. There's a lot of metadata fields, frankly, that are optional. You can create a pretty bare bones Sigmf recording that doesn't actually say that much about what's in the recording. But in all cases, there are required metadata fields that without the Sigmf recording is considered non-compliant and broken. And one of those is data type, specifically for that reason.
We are continuing to add data types for support directly in Sigmf as is necessary. There was a request recently to add float 64's double floating point numbers, which previously wasn't supported, but it's a MATLAB thing, and there are a lot of existing data sets stored in that format. So that'll probably be a feature in 1.1.
So one of the things that we always have tried to balance is what new requirements does adding a feature like that, for example, place on software designers. So, for example, if and when support for double precision floating point gets added, that means in order for an application to be Sigmf compliant and to maintain that guarantee that if I receive a Sigmf recording, I will be able to, for example, do what Jacob's doing here and load it into InSpectrum and know it's going to work. That means that those application developers must have a way of supporting double precision floating point on their system. Now, that example sounds relatively simple. There are plenty of examples where that's not true, especially when we start looking at lower swap embedded system kind of hardware.
On that subject of compliance, one of the things that was added in the version 1.0 specification was explicit language on what compliance means and what it means if you want to call an application you've built or a data set you've built Sigmf compliant. This language is in the spec now at the very bottom here, and it runs through exactly what is required. Now, Ben and I are not an enforcement agency. You do whatever you want, but to adhere to the specification, if you'd like to advertise an application as compliant or a data set as compliant, and get the benefits of that, which is universal understandability, take a look at the specification here and see what's required. One of the other major features in version 1.0 that came out of our last workshop at GRCon in person was the concept of canonically defining non-conforming data sets. Ben touched on that earlier, but this is an area of great complication, really. And so one of the notes that you'll see in compliance is an exception that compliant applications are not required to support all aspects of non-conforming data sets. Ultimately, this was a decision that came from the fact that there are just a tremendous amount of edge cases with non-conforming data sets. We see the value in allowing that. It's very easy to determine if a data set is Sigmf compliant or if it's non-conforming. But it's a bit of a dangerous area. You know, I think we would definitely suggest that you build data sets that are conforming to the Sigmf specification. But sort of to the point of, I have a bunch of data and I want to make it Sigmf parsable, there's an advantage to allowing non-compliant data sets within Sigmf. You know, Vita49 is a good example. There's also Midas is a standard that has a header included in the data set. That would have been prohibited by Sigmf as the data set is entirely time series data. But through non-compliant data sets, you can support for a header, a footer, intermittent headers in the data, different segments. It's just a bit of a dangerous area. So
we got 2 questions in the chat. And actually, Jacob, can you pull up the wiki and navigate to the logo page? I'll answer Andy's question. And actually, before I jump over to Stephen's question as well, one thing I'll say is we keep on the note of compliance, and one of the reasons that non-compliant data sets are difficult is the Sigmf specification goes through really great care to make sure that there is not ambiguity in any of the data. And that sounds simple, but it's, I think, actually probably one of Sigmf's greatest successes. And so to give you what sounds like a very pedantic answer, but breaks real world systems all the time, right, is if you have some inlined header, for example, in Midas or Vita49, that describes how much data is in a payload, but then you sort of sum all of the bytes in that payload, right? And on disk, it ends up, you end up one byte off, right? What does that mean and who's right? Right? Is that extra byte sample data or is it not sample data? And you end up in situations where you sort of have to flip a coin and hope that the authority that you chose for that particular question happened to be the right one, and you're interpreting your data correctly. And there's several cases where Sigmf chooses to put additional burden or avoid things or avoid options that would be very convenient, specifically to avoid that scenario. So another really, really basic example of this is there is not a field that describes specific, effectively, payload length within a singular capture. And that's because it would be redundant to the information you already have between what is the data type, right, and how many samples are actually on disk. And if we provided that convenience field, you could end up in a scenario where these two multiplied together don't equal this, because the writer application recorded it differently, something went wrong somewhere in transit, right? There's all kinds of different ways that those could disagree with each other. And avoiding those kinds of scenarios in all cases is one of the major design goals. And that's kind of part of one of the major, or one of the most substantial design requirements behind what we mean by compliance and the way the specification is laid out itself. So Andy, one of the things that's currently missing from Sigmf is a really great library of examples. There is not, and one of the things that I know Jacob has been working on, for example, that isn't ready yet, is a pretty comprehensive example of a Sigmf collection, including multiple recordings that are all linked from different channels, and you have different types of data that are not RF data, right? That is not an example that it exists in the public in the canonical Sigmf repository today. There are two places that I'll point you to of really, really great Sigmf examples. So the first is the Sigmf logo itself is actually a Sigmf recording. It's a Sigmf recording of dual channel oscilloscope data. That recording is available through the wiki. You can download the raw recording and deal with that data. The other place that I will point you to, and actually it would be good to link this, is Dr. Daniel Estevez, who is a professor and researcher and regularly uses the Allen telescope array, has regularly published Sigmf recordings of observations he's made at the ATA. Most recently, he's published a bunch of Sigmf recordings he made of the James Webb Space Telescope. He's also published recordings from the ATA of Voyager and other satellites. And those are all Sigmf compliant. They're all publicly available under open source licenses. They're all tagged with, Zenodo IDs if you want to reference them. Those are all publicly available, and and actually we should add a link to those in our wiki, Jacob, so that we don't have to keep digging it up. If you're looking for like a really pretty sizable, RF collection that looks like multiple channels, there's a lot going on, you care about labeling stuff in there, right? That's a great place to start. Steven's question: is there a way to manage and annotate data sets of integrated power spectra? So I think what you're asking very specifically, is there a way for a data set to effectively be a vector of PSDs? Sorry, not PSDs, spectrograms. Is that accurate? Yes. Yeah, so this actually came up several years ago, and we decided not to do it. And I think there's good arguments to be made on both sides. Fundamentally, it's outside of what we had set out to achieve with Sigmf, in that the power spectra itself could always be recreated with the samples that you had, but you couldn't do it the opposite direction. That said, I think now that we've hit our 1.0 tag, I think those are exactly the kinds of questions that we should come back to. There are a lot of really good arguments made for why that would be really, really useful, and how basically being able to tie Sigmf metadata to pre-processed samples where you only care about power spectra, right? Perhaps, not even continuous power spectra, would be extremely useful. So I think that's a really, I think that's absolutely something that we should come back and readdress. We said no last time, and it wasn't necessarily because it wasn't a never, it was a not now.
I think we inadvertently actually allowed for a fairly simple way to do that, even with the 1.0 specification. One of the other features that we haven't really discussed is the ability to have more than one time series interleaved. You could effectively extrapolate that to a 512 channel time series where each channel is an FFT bin, if that was your intention, and it would be reasonably would not be a complete abuse of the specification. That's not an on-label use of that right now, but it does conform to the only requirement, which is that each channel must be aligned with every other channel.
Yeah, and actually to Steven's point, and tying this back to something I said earlier, when we first created Sigmf, to be totally honest, there was nobody from the radio astronomy world involved, and it wasn't something that I personally had in mind. I'm not a radio astronomer, despite how amazing and cool I think it is. Since then, Sigmf has been adopted very heavily by radio astronomers. So I think what you've raised is right. You hit the nail on the head. Strong agree. So we had another question here from Kevin. Does Sigmf only apply to RF, or would CPRI? So CPRI is the Common Public Radio Interface. It's commonly used for, this is general for anyone who's not lived in the world of cellular, heavily used in the world of cellular for remote radio heads. And it provides a mechanism for both, it's a synchronous, clock synchronous transport. So it provides a mechanism for data as well as effectively like sharing a 10 megahertz reference over the transport. Kevin, did I describe that well, by the way? It's been years since I've touched CPRI. That's my recollection of it. Anyways, does Sigmf only apply to RF, or would CPRI streams be able to be either converted to or annotated by Sigmf? So the answer is no. Sigmf does not only apply to RF. Sigmf currently applies, it can apply really to anything that has a concept of a sample clock, frankly. If it has a concept of a sample clock and it's a digital recording, then you can describe it in Sigmf. And actually, I know of examples that are not public of Sigmf being used in particle physics, which I guess you could sort of say is kind of like RF, but in this case, it's not quite. But yes, so you absolutely could use Sigmf to describe CPRI. There's several different ways you could go about it. You could break the different signals out into their own recordings and tie them together via collection, or you could just do, sync effectively the entire channel, wired channel, right, into a single recording, and in your Sigmf metadata, specifically lay out what's in that in the JSON if you didn't want to break it out separately. So Jacob, we haven't actually gotten into any of the future looking discussion that you had wanted to yet. Questions have been good though. Does anybody else have any questions like these so far?
Feel free to keep them coming in the chat, and we will jump over.
You're always storing new data. Here's what I would say, Ryan, because there's a lot of use cases like this. So one of the changes that happened, so early on in the version 0.0.1, the specification was pretty strict that Sigmf could only be used at rest. And then no aspect of the specification could be used not at rest, which does not fit your use case. That's no longer true. And so one of the things that we discovered was even where the at-rest format didn't apply, there were a lot of users who were using our approach for metadata. And so what we did in the version 1.0 spec is we delineate between what's effectively the Sigmf metadata schema and the Sigmf format. And so in your case, right, you have the data and ring buffer that's constantly being written and rewritten, right? That's not, right, a Sigmf compliant recording. But if you have a use for being able to describe that data with metadata, right, you absolutely could use the Sigmf metadata schema in a schema and be Sigmf compliant in that schema, right, to describe that data in memory. And so, if you had lots of data that you were storing in ring buffers and you had something else that was looking over the metadata and deciding what to do with that data based on what you see, or pulling out snippets, or what have you, depending on the metadata. Yes, the metadata schema itself, are mechanisms for describing extensions, all that kind of stuff could very well be very useful to you. but the on-disk storage format would not apply.
This is an area that will have to be sort of explored further as we integrate Sigmf into GNU Radio directly, where you do have data not at rest and you're attempting to, describe pieces of it or all of it. Okay. I put up an example here that I had earlier, which is in Spectrum, that is showing off a RF recording from a cell band, and it's been labeled by the content of some of the signals. This is just one example of how you may go about using annotations and rendering them. In this case, these are data sets that are used for RF machine learning, and annotations are used to label the ground truth of them. Many possible examples there, but in Spectrum is just an excellent way to start using annotations and metadata within Sigmf. Some other sort of noteworthy things: it's automatically going to pull in the sample rate of the data. I could have had any of the supported data formats behind here, and it's going to render it. Things like that are all aspects that sort of lead into the next piece, which is talking about GNU Radio and as how GNU Radio will use Sigmf. This is an area that I think overall the community could use input and help with. I think there are some basic ideas. The idea that if I have a recording that I'm reading in with GNU Radio, I want to know the center frequency of that recording. I want to know the sample rate. There are fundamental things that are always important, the data type. However, particularly when it comes to generating Sigmf, there are some questions about the best way to manage that. Oftentimes within a flow graph, you'll have more than one sample rate or more than one center frequency. There are a lot of areas that, in terms of how this can be more seamlessly integrated into GNU Radio overall, that could use a little bit of assistance and input from users. I suspect the initial use case will be very similar to the existing gr-sigmf, where you have the ability to manually define these parameters and generate Sigmf compliant recordings from GNU Radio or read them in. But I think moving forward, having those parameters be usable by other blocks through an existing mechanism of GNU Radio is going to be important in terms of seamless integration. There's not a tremendous amount to talk about on that front. I expect that there will be discussion about this in the coming months, probably on chat.gnuradio.org. So input is very much welcome there. Okay, let's see. The next subjects I was hoping to talk about really have to do with current Sigmf backlog. This is moving a little bit into the specification development area, and I understand that's not necessarily generally of interest. Everyone is more than welcome to hang around though. Any questions that come up, we'll jump over to those, but I did want to run through a couple things specifically that came out of our last working group from GRCon. That was the concept of metadata-only distributions that would be used to generate data sets dynamically. So the idea there is that metadata would be the schema file would be passed, would be the only data product that is actually stored permanently, and it would be used to generate a Sigmf compliant recording just in time. This is an unanswered. I think there are some open questions that we still have in the discussion of this bin. This was not something that was directly implemented in 1.0, But I will also note that Kyle was a large contributor to this, and he's not here, I don't think. So we don't have to dwell on this too much. I did want to bring that up as something that Sigmf is considering, though. Another area that we were soliciting input had to do with compression. This was another unresolved area for 1.0. We do define the ability to provide a Sigmf, what we call an archive, which is a single file that is a compressed representation of the data file and of the data file and the schema. There are some open issues related to that on our GitHub page. And then the other major topic related to this was a website. We need a website and better documentation. I know Mark has been working on the README. Thank you very much, and other people have as well. Ben, is there anything to discuss about that? Do you need anything at this point in terms of?
Oh, by the way, you're still sharing the InSpectrum screen. I don't know if you were trying to step through your slide.
Whoops. Thank you.
All right. Yeah, and back on the generator side, just for anybody who's interested in only passing around effectively the metadata to then generate compliant recordings on the fly. Just to clarify, so there is a metadata in version 1.0. There is a metadata. There's a provision for distributing metadata only Sigmf files, right? So you could already, from that, depending on the what was in it, generate a recording. There was sort of further description of how far do we want to take that. So in the circumstance, for example, where you cannot generate an accurate recording on metadata alone, would it be useful to distribute a GNU Radio flow graph plus a Sigmf metadata file, where you pointed to one from the other and could recreate synthetic recordings based on the metadata? So there are some use cases for that there. If you have thoughts or input on that, we would love to hear it. What's currently in the spec is going in that direction, but not quite there yet. Sorry, Jacob, what was your question to me just now?
Website, making Sigmf more approachable.
Yeah, so kind of going back to our point before, Sigmf taking off way faster than we anticipated taking off. It doesn't really have a website. The landing page is basically the GitHub README. For anyone who is interested, there's a lot of work to be done in actually just lowering the barrier to entry for Sigmf and making Sigmf understandable without having to read the spec, as in what are the problems that it's solving in a way that I can quickly glance at our website and get my questions answered, as well as building out examples in the wiki. If anybody enjoys doing that kind of work and wants to contribute to Sigmf without necessarily participating in debates around very pedantic language choices and a specification, that is a great way to get involved. So just let us know.
Yeah, I think a big part of that, and we've discussed this, will be providing some more examples. As part of the libsigmf QA, I'm attempting to provide a range of metadata for parsing, and I think we'll attempt to include minimal and typical and extremely verbose examples accessible through a single web page. Jeff, yeah, that is a consideration when it comes to generators. That yes, foot guns. There are situations where you are going to want repeatable data. There are situations where repeatable data is not going to be possible because it's underdetermined. It is a a reasonable consideration. Knowing whether or not it is repeatable is probably the best that we're going to get to, I think, in terms of as far as the specification will be concerned. I don't think we will levy any requirement on repeatability because there are plenty of cases where that may not be necessary. So moving into some forward-looking aspects, one of the things I wanted to chat through are the canonical extension list. I'm going to switch back over to sharing my web browser real quick. Currently, we have a handful of canonical extensions in here. Some of them are signal specific, Wi-Fi, ADSB, for example. I think these are important to provide as reference examples. I do not anticipate us continuing to build out some sort of complete signal library. The other examples are intended to be a little bit more generic, with the exception of the RFML one, which this one is a little bit specific, and it's actually slightly confusing to me as to how it is intended to be implemented. So I think we need to have a discussion on whether or not this continues to exist as a canonical extension for widespread support, or if it gets at any level, it's going to need a little bit more definition. I sort of arbitrarily chose this to be a string array, as it was not clear from the initial proposal of this. I don't know if you have any of the history here, Ben, but I have considered removing this as a canonical extension or proposing that.
So this one really needs examples. I wonder if there's not.
It does.
No riff mill examples. Okay, that's interesting. So the background here is this extension was designed by NSWC Crane and upstreamed actually by Crane. If you look at who the contributor and the Git log behind this, it's a bunch of engineers at the Naval Surface Warfare Center, Crane. And they also had a lot of data sets specifically using this. And they provided some examples of those. I see that, I don't know why those aren't linked here. The data sets themselves cannot be made publicly available, but certainly we ought to be able to make examples that make use of this more clear available. So I actually, for some reason, I thought there was more information in this file than it looks like there is. So I'll go figure out where that information is. But that's the backstory here. And it was fundamentally designed to support exactly what you see, RefMill.
Well, if anyone else is using that, I would definitely be interested in hearing more about it. It's hard to have a canonical extension with no public examples, so maybe we need to lean on some folks there to help out with that.
Maybe
One of the other examples that I would like, or the other extensions that I would like to see included is spatial extension. This is an earlier a 0.02 version pull request that I submitted, but the idea here is to provide some specificity on different coordinate reference schemes for coordinate reference systems for RF direction finding, beam steering, beam forming type applications, specifically as it relates to multiple phase coherent data sets. I have had input on this from a number of people who do this type of work and would benefit from this. However, I would like to get more input. I think this is a highly valuable thing now that we support collections. Multiple channel phase coherent radios are much more common than they have been before. So I wanted to draw some attention to this and see if there was any other thoughts on this. especially as we move forward with 1.0 done, I'm going to start trying to get this either included, or possibly, you know, I can also maintain this with my DeepSig hat on our webpage. But I think this is a little bit more generally useful than just what my company needs. So, and it includes examples, as all of these extensions should. The other extensions that I had considered a presentation extension, and this would be something like that would be of particular interest probably to tools like in Spectrum, where you could specify some presentation features of the annotations themselves. I wrote a quick example for in Spectrum that allowed you to color boxes differently, for example, or provide transparency to boxes and annotations. This is helpful if you're trying to if you're using annotations for multiple things in multiple different things in a data set, and you don't want to use the label, just the text label, to do that. Ultimately, I pulled that back. It was just a proof of concept, but I think a presentation type extension would be helpful in terms of visualization. Back to my agenda for the workshop. I'll jump back to that slide real quick. We have covered more and better examples in documentation fairly well. The only other item I had specifically in terms of v1.1 and 2.0 is tool expansion. There, within the Sigmf Python module, specifically related to our inclusions of different types of data sets. Historically, it was a single time series, a single continuous time series data stream in a Sigmf data set. That's changed a little bit, and providing some better tools, specifically with the objective to provide ease of memory mapping data on disk into an application. I think we have some work to do there. There are also a number of open issues on our GitHub page regarding Sigmf validation. There are definitely questions of, is this Sigmf or is it not? And a quick way to determine that is helpful. That's really the things that I wanted to discuss today. I certainly, this is intended to be interactive. If anyone has anything related to Sigmf they want to bring up, please jump off mute, jump in chat. I will draw attention on chat.gnu-radio.org. We have a room for Sigmf discussion. It's a very convenient way to get a hold of Ben, myself, any of the GNU Radio team about Sigmf specific questions, issues. Show us if you've done something with Sigmf that you can show. Link it there. It's of general interest.
I also say you don't have to. I know that the barrier to entry to working in other specifications and standards bodies is often extraordinarily high, right? Kind of going back to the top, one of the goals of Sigmf is very specifically not to be that. And you do not have to be interested in wordsmithing language within a specification in order to file a bug or make a request or ask a question or call out something you think would be useful that the current specification doesn't provide for. So don't feel like you have to become, part of the critical path in a specification debate in order to jump into the GitHub and file bugs or discussion items. That's frankly, I think one of the reasons why Sigmf has had the amount of contributors that it has.
Since the main content has wrapped up, I propose stopping the recording at this point, and we can kind of just open forum it. And I know, Ben, you have to exit fairly soon here. Thank you very, very much, Ben and Jacob, for going through all of this and for pushing Sigmf to the 1.0. I know that that's been a lot of work, particularly over the last couple of months, to hash out the final details, and there's been a huge amount of attention to detail paid. I'm sure that we'll see a lot of that work pay off over the next couple of years, but hopefully you don't feel too tired having reached this milestone and can start enjoying the fruits of your work. So thank you very much.